Welcome to The Explainer. Today, we're cracking open a document that basically changed the internet forever. It's just 9 pages, published way back in 2008 by the mysterious Satoshi Nakamoto. Now, this paper didn't just introduce Bitcoin, it laid out this wild new way for people to exchange value online, completely cutting out the banks. So, what was the big problem it was trying to solve, and how did this super elegant solution actually work? All right, let's break it down.
This one sentence, right from the get-go, lays out a truly radical vision. I mean, think about it. Back in 2008, every single time you paid for something online, it had to go through a middleman, a bank, a credit card company. And here comes Nakamoto saying, let's get rid of them, all of them. To really get how huge that was, we have to look at the problem with the system we were all using at the time.
So the white paper kicks things off by going right after the single biggest weakness in online commerce. And it wasn't about security or speed. No, it was all about trust.
Right, so this is the world we were living in. Every time you bought a book, sent a few bucks to a friend, your transaction had to pass through a central gatekeeper. And Nakamoto argued that this whole system, while it mostly works, has an inherent weakness. And the biggest one? Well, it's the fact that unlike handing someone cash, these digital payments were never really truly final.
Think about it. When you hand someone a $20 bill, that's it. Game over. The transaction is done. But online, payments can be taken back. And that's because these financial institutions, they have to step in and play referee for disputes, which leads to things we all know, like chargebacks.
And having this referee involved in every single transaction has real costs, stuff we've all felt. It drives up fees, which is why buying a cup of coffee with a credit card used to be a big no-no. It forces sellers to collect all our personal data just to protect themselves. The goal of this paper was to build something totally new, a payment system built on cold, hard cryptographic proof instead of trust. So, if you're going to build a whole new kind of digital money without a central bank, where do you even start? Well, you have to begin by defining what an electronic coin even is. And Nakamoto's definition is just beautifully simple. So a coin isn't some file you just send to someone, like an email attachment. Nope. Instead, it's this continuously growing chain of digital ownership records. To pass the coin along, the owner signs a hash, which you can just think of as a unique digital fingerprint of the last transaction. Each new owner adds their fingerprint to the one before it. And boom, you've got a chain.
What this does is create this perfectly auditable history of ownership for every single coin. Anybody can look at that chain of signatures and prove without a doubt who the current owner is. But, and this is a huge but, this elegant solution to ownership creates a massive new problem.
And here's the problem. Since this is all just digital information, what's to stop me from sending the exact same digital coin to you and then also sending it to someone else at pretty much the same time? How does anyone know which payment was the real one?
This right here is the famous double spending problem, and it's the absolute biggest hurdle that any decentralized digital cash system has to clear. It is, for all intents and purposes, the digital version of counterfeiting. Traditional systems, they solve this pretty easily. They have a central authority, what the paper calls a mint, like your bank or PayPal. They see every transaction so they can just reject a duplicate. But Nakamoto's whole mission was to get rid of that trusted middleman. And this, right here, is where we get to the absolute heart of the invention. Instead of putting our faith in a single company or bank, the solution is to create a public history of every single transaction that has ever happened, a history that everyone on the network can see and, most importantly, agree on.
The paper actually calls this a timestamp server. But think of it like a public ledger that everyone shares. New transactions get bundled together into these things called blocks. Then each new block is cryptographically chained to the one that came before it, which makes it basically impossible to change. And this very structure, this chain of blocks, is what we now know as the blockchain. Okay, so with everyone participating, who gets to add the next block to the chain?
This is where the sheer genius of proof of work comes into play. To earn the right to add the next block, participants, or nodes, have to use their computers to solve an incredibly hard but totally random math puzzle. You have to prove you've done the computational work. The paper compares it to gold miners spending real-world energy to dig gold out of the ground. Here, people spend real electricity and computer processing power.
It's really a brilliant way to let the whole network vote on which transactions are legit. But instead of one person, one vote, it's one CPU, one vote. Your say in the network isn't about who you are. It's about the raw computational power you're willing to throw at it. It's basically a democracy of processing power.
So, with all these different people potentially finding blocks, how does the network agree on which version of history is the right one? It's actually super simple. Everyone just agrees that the longest chain is the valid one. Why? Because it represents the most proof of work, the most computational effort. And that is how a totally decentralized network comes to an agreement.
Now, this all sounds pretty clever, I know, but it brings up a really important question. Why on earth would anyone dedicate their computer and pay for the electricity just to solve these puzzles and maintain the network? Well, the answer, as it is with many things, is money.
The system has these built-in rewards for playing by the rules. If you're the one who solves the puzzle and adds the next block, you get two things. First, a reward of brand newly created coins, and second, you get to collect any transaction fees that people included in that block. This elegant system of incentives is basically the economic glue that holds the entire network together.
Okay, but the paper addresses the elephant in the room. What if a really powerful attacker tries to cheat? Now, they couldn't just create money out of thin air. The network's rules would just reject it. But what they could try to do is reverse one of their own transactions. So, for example, they could pay for something and then try to secretly build a longer, competing version of the blockchain where that payment just never happened, letting them get their money back.
The paper actually models this as something called a gambler's ruin problem. It's basically a race between the attacker's chain and the honest network's chain. And as you can see from the numbers right here on the slide, the odds are just stacked against the attacker. I mean, look, even if they controlled a whopping 30% of the network's power, once 24 blocks have been built on top of a transaction, the chance of them successfully reversing it drops to less than 1/10 of 1%. It becomes computationally impossible fast.
And this, right here, is the fundamental security promise of the entire system. As long as the majority of the computing power, the good guys, are playing by the rules to get the reward, the network stays secure. It's as simple as that.
So let's just put a bow on this. In just 9 short pages, Nakamoto laid out a complete self-sustaining system from top to bottom. It swaps out trusting banks for the certainty of math. It defines a coin as a secure, verifiable chain of ownership. It solves that critical double spending problem with a public ledger we now call a blockchain. It uses proof of work to let a decentralized network agree on a single version of the truth, and it powers the whole thing with economic incentives that make it more profitable to be honest than to cheat.
Look, this wasn't just a proposal for some new internet money. It was a blueprint for a whole new way of doing things online. This core idea of replacing our trust in big institutions with trust in code and mathematics was a profound shift. And whether you think it's a brilliant innovation or a risky experiment, that one idea has kicked off a global conversation about the very nature of money, trust, and power that is still going strong today.